Okay, I don't want that. Learn.sun.ac.za. Okay, there is a small chance that that these mics will interfere and you won't hear anything. So there's a small chance of injury. Come on, guys, you're late. Run, Forrest, run. Find a seat. Okay, so we are supposed to talk about, just close the blinds a little bit, please. Okay, we are supposed to talk about arrays because you need those, but I was a little upset yesterday when during the TUT, many of you, some of you, struggled a little bit. And I don't want that. Okay, let's see. Oh, there we go. I don't really want that. I want you to succeed and be able to do the TUT problems easily. Not necessarily quickly, because, I mean, you are still learning, but it shouldn't be so much of a struggle. It is not acceptable that you take an hour on that first problem that calculated the interest, or not be able to do the pi thing, Ivajik. So I want to do the pi problem in class today. I know it's not arrays, but maybe we can get around to arrays. If you can program, I know it's tedious to watch somebody else do something simplish, but if you can't program, please pay attention, because I'm not showing you how to write the program. I don't want to teach you anything in this course, except how to think in a certain way. So what I'm trying to convey is how to think about the problem. Okay, so let's just quickly do the pi problem. Oh, this is so slow. I'm going to die. Okay, it's coming, it's coming. So the idea was quite tricky. It wasn't straightforward. It wasn't really very difficult, but it wasn't perfectly straightforward. So the question asked you a few questions about a circle inside a square and how you would use that to calculate pi. So it says, imagine picking a random point. What's the radius of the circle, what's the area of the circle, and so on. And then it goes on to say, write a program pi.java. So we can start with that immediately. Public static void main string args. And please watch that I'm not making horrible mistakes. Okay, fine. Write a program pi.java that reads an integer from the command line. Now, you must all have been able to do that. I was horrified that people stopped and said, I don't know how to do this. Because at the very least, you could have written just what we always write. I have some integer n, which I get from the command line. Keegan, yes, Keegan. Shh. You're whispering at the wrong frequency. The integer denotes the number of points our program has to pick. So our program has to pick a number of points, not just the one in the example above, but several points, all random, and it should pick n of them. So repeatedly, it must pick a point n times. To me, that immediately suggests a for loop. I still don't know exactly how it'll work, but I'll have some kind of for loop. And inside the for loop, every single time, what I'm going to do is pick a point. I'm slowly filling in the program, filling in my thoughts. Even though I don't know exactly what I'm supposed to write here, and it may all be wrong and I backtrack again, I'm starting to compose the program in this way. The program must print the value of pi it calculates. Oh man, okay, so how are we going to calculate pi? Well, this actually explains. Let's call the number of random points that fall inside the circle K, that fall inside the circle K, and the area of the circle is AK. And the number of points that fall outside the circle we'll call O, and the area outside is O. And then this little paragraph explains that K over O, so the number of points inside and outside, that ratio is equal to the ratio of the areas. I'm going to throw a lot of random points at the circle, or the square at least. The ones, I'm going to count how many land inside, and the ratio of inside to outside will be the same as the ratio of the areas. Now, if I only throw 1 point, I'll have 1 versus, let's say the 1 point is inside. I'll have 1 versus 0. That's not a very good approximation. If I throw 2 points and one is inside and outside, I get 1 to 1. But we know that's not a good approximation either. But the more points I throw, the better will be my approximation. So if I throw 1,000,000 points, some will land inside the circle, some outside, and the ratio of those counts will be quite an accurate approximation of the ratio of the area of the circle to the area outside the circle. So I'm going to use my count as an approximation. Okay. So repeatedly, I'm going to pick a point, check if it's inside the circle, and if it is, I'm going to update that count. So let's just write that code. Pick a point. So I have to pick a point, an x and a y position, and they'll probably be doubles, as in the little example. Oh, pick random. There I've picked a point. And if inside increase count. So I've refined the idea of picking a point by converting it to 4 tasks. Picking a value for x, picking a value for y, checking if it's inside, and increasing the count. And of those 4 things, which is easiest? No. No, I don't think so. I think we can all agree that increasing a count is the easiest thing to do. So I'm going to say the count, which I'll call k, starts at 0. And to increase it, I'm going to use my new post-increment operator that I've learned and just say k++. OK? Pick a random value, x. Who agrees that it should be a double? Okay, who disagrees that it should be a double? X, yes. Okay. Thank you very much. Lauren, who sits next to you? Michael, whatever. Michael, who sits next to you? What? Arno? Andre. Andre, double or not? You haven't voted. You just sat there like you're on the beach. I see. Okay. That is sad. Well, I think it definitely should be a double because in this sketch, here was a point and its values were, x value was 0.25, y value was 0.5, so it definitely should be a double. But Andre, what's the range of this double? What's the minimum value that x can have?
1.
The minimum. Will it never be smaller than 1? Because 0.25 is smaller than 1. The minimum will be 0. Andre, are you sure? Don't be afraid. Stand by your opinion. I'm just sometimes ragging you, and just to make sure that you're sure. Minimum 0.
Bigger than 0.
well, okay, minimum is 0. Okay, because you agree that this point, right on this line, it's inside the circle, and its x-coordinate is 0. Do you agree, Andre? Okay, what's this trick? So, nothing in my hands. Okay, now, whoa, look at the cursor. Okay, does it point to a point? Andre, yes or no?
Yes.
Is the point inside the circle? What is its x-coordinate?
Well, it's smaller than 0.
What is its x-coordinate? Just answer the question. What is its x-coordinate?
It's a negative x, I don't know what.
Well, roughly minus 0.5-ish, I'd say. Maybe minus 0.4. Is minus 0.4 bigger than 0 in your words? Did you not use that word in this course? I mean, this classroom? So, would you like to revise your earlier answer? What's the minimum value for x?
-1.
Okay, right. Can it be less than -1?
No.
You say that very confidently, almost as confidently as you were about the bigger than 0.
Because then it's not either in the zero.
Okay, right. So -1 is definitely the minimum value. It can be -1. This point is exactly -1, but it can't be less than -1. Okay, Andre, still sticking with you. I'll be done with this witness in a second, Your Honor. Okay, so I'm going to say here, math.random. Happy, Andre? What value does math.random return?
Well, yeah, you have to specify the range.
I can't. I can only, it doesn't take any parameters. Does it? I don't think so. What value does math.random return, Andre?
Between 0 and 1.
Okay, but we want from -1 to 1. How are you going to fix that? Shh, Andre is thinking. While he's thinking, let's move to Michael. Johan. Oh, Michael, Johan, it's the same thing. Johan, how are we going to fix that? How do you know that? Just no. Wow, that's amazing. Okay. So the issue is that math.random will send back a value that's from 0 to 1. But that's not what we want. We want -1 to +1. So what Johan is suggesting in his childish naivete is that we multiply this by 2. So now we still have a random value somewhere from, somewhere from 0 to 2. The smallest value that math.random times 2 can return or can be is still 0, but the maximum value is now +2. And then, yes?
Does it return 1
Let's say it does. 9. Is that the same as 1? Well, you sort it out with Keegan because he disagrees. Okay. So, -1. We're going to get so close to 1. It does not ever return exactly 1. But it's so close to 1, it's not going to affect our approximation. That's the important thing. Good. Good. Excellent. If I subtract 1 from this random value, I don't know what it'll be, because math.random sends back a random value every single time, like rolling a dice or die. But if I subtract 1, it'll be somewhere between -1 and +1. Do you agree, Andre?
Yeah.
Don't agree just because I tell you to. Don't believe in authority. I can make you agree with anything, I think.
Excuse me.
Yes.
Is this even necessary? Because if we think like probability, then 1/4 of the circle,
Yes.
the way the dots will fall in that quarter is just as evenly or unevenly spread as how they will fall out of the other quarters. So why even bother doing this? Just leave x as math.random and y as math.random and just cut. And in the end, you're just working with that quarter, but it'll be the same.
What a brilliant idea.
I feel like you're going to berate me.
However, small tiny issue, and that is there's a small mathematical issue that we are going to run into if we do that. So let's put it on the back, on the stack, and get to it in a second. I'm going to pick y in exactly the same way, because y2 must lie in those bounds. And all that remains is for me to ask if it's inside the circle or not. So how do I know if a point is inside the circle or not? Radius 1. Thank you very much. You're not helping the learning process, because people need to figure this out and they need to struggle. You need to struggle against something. You need to have some opponent, an antagonist, your ignorance that you can conquer. Okay, so we definitely know what the definition is of all the points on the circle. They're exactly all distance 1 from the origin. If I move closer, I'm moving into the circle, and the distance to the origin becomes less. So all the points inside the circle have a distance to the origin of less than 1. All the points exactly on the circumference has a distance 1, and all the points beyond the circumference has a distance greater than 1. So all I need to calculate is the distance. Now, 2 attempts. Lauren, don't interrupt. Okay. Attempt 1, distance. If the distance is less than 1, that's inside, not on. So I just need to calculate distance. And in fact, we did this in the last stat, and you may not recall exactly, but we did do this, and you should go back and look at it again. It's just Pythagoras' theorem. And in fact, I'm just going to substitute this whole expression in here. Okay. Now, x can be from -1 to +1. Y can be from -1 to +1. But x squared is always positive, isn't it? And y squared is also always positive, isn't it? So I'm taking the square root of a positive number, which is good. I don't want to take a negative square root. If I have a is less than b and they're both positive, can I square both sides? A squared is less than b squared. Does it work the other way? If I have a squared is less than b squared, can I conclude that a is less than b? Only if they're both positive. So have to have that. But I do have that in this case, so I don't have to be afraid of squaring or taking square roots on both sides. So I'm going to do something a little radical. I'm going to take the square on both sides. 1 squared, 1, good. And I'm just going to, I like writing spaces around operators, but sometimes it just looks a little neater if I don't. Okay, why did I do this? Let's find someone who did programming at school and considers themselves an expert programmer. Math is not good, but can program. Okay, fine. Let's pick a random person. I've already forgotten your name again. Vincent, Michael, Barry, John, Jackson, Eli, what? Okay, I will. If I can remember anybody's name. The only person's name I can remember is Kiara. Kiara, why do I want to do that? Because I'm an intelligent person who thinks about what he's doing and writing. I write consciously. I don't just blurt it out. I'm thinking the whole time. And I thought this might be a good idea. Do you agree? I wrote this because math.square root is not wrong, but it's an extra operation. And in fact, it's quite an expensive operation to take the square root of a number. We should know because we did it ourselves. Do you remember we implemented the Newton-Raphson method for taking the square root? And it's quite involved. And that's exactly what the computer is doing when it's taking square root. So I can make my program a little bit faster and a little bit clearer if I forget about the fact that I have to take square root for distances and work with the fact that I can square both sides and still get the same answer. So what I'm really asking here, if the square of the distance is less than the square of the radius. But this also implies that the square root of, so the distance itself will be less than the radius. So if it's less than 1, I increment k, that my count. Oops. And at the end, I have that k is the number of points inside the circle. N is the total number of points. N minus k is number of points outside the circle. Okay, right. We're almost at pi. Is k over n or k over that other thingamajig, is that equal to pi? Who completed this exercise by themselves in the past? Not over the coming weekend or in the future I will do it. Who actually completed this exercise? Is this number pi? According to you guys. K is not pi, for sure, because k can be like in the millions. Is this ratio? Is that pi? No, that's 0. Because k is an integer and n is an integer. Divide to integers, do integer division. N is guaranteed to be bigger than k, or at the most equal. So it'll go either 0 times or once into k when they're equal. So that's definitely not pi. But let's make it a ratio. So I'm going to first multiply by 1.0. Okay, now, is k over n pi? Don't think so, but let's try it. I don't know. That's not true. I do know, but let's just go for 1,000. Okay, that's definitely not pi. Okay, maybe it's the number of inside points over the number of outside points. So that should be n minus k. Maybe we're lucky. Oh, looks good. Starts with a 3. Oh, not bad. Oh, but it just went up. Oh. Up again. It's looking like it's going towards 3.66. Definitely not the pi I remember from school. Okay, right. So this is probably, say again? Pi has changed a lot over the years, yes. But it's only become more accurate. But this is probably not pi. So if I can't just guess this, I have to go back to the kind of drawing board. The program never said that these ratios are pi. It only said that we must use the formula for the areas to find it. So what if I have radius r? What is the area of a circle? So that's pi times radius squared. Just going to write it like that. Okay? And what's the area of the square? So the radius is r. The side of the square is 2r. So the area of the whole square will be 4 times r squared. Say again?
I mean, you could just stop it at 4.
What?
You could just stop at 4. Like,
I can just stop at 4. Yeah, of course. In this case, yeah, you're absolutely right. In this case, this particular square has area 4 because its sides are 2, because r happens to be 1. But in general, because maybe next time you see this problem in the test, it'll be more general. It's r squared. Okay. Let me reconvince you. So this radius, in this case it's 1, but let's call it r in general. The distance from the origin to this edge of the circle. This is r. That's r. Do you see r? Can you see it? Yeah. From the top of the square to the bottom. So the diameter of the circle is 2r. So the side of the square is 2r. And the area of a square is side times side. So it's 2r times 2r, which is 4r squared. Hang on. Pi is 1, did you say? Okay.
R is 1.
Yes, in this case. In this case, r is 1. I know that. But in general, if the circle's radius was not 1, but r, then I have to work in terms of r. You agree? No, you don't, but never. 2r times 2 times r is equal to 4r squared. Okay. So, the ratio of the circle to the square is pi times r squared divided by 4 times r squared. And the r squares cancel out, so the ratio of the circle to the square is pi divided by 4. And so, pi is equal, if I multiply both sides by 4, 4 times this ratio. And I don't know the ratio, but I have an approximation for the ratio. The area of the circle is the number of points that fell inside the circle, which is k. The area of the whole square is the number of all the points that I've actually picked. All the points I picked fell inside the square. Was that true, Andre? Yes, that's how we designed it. So that's n. Is this correct? Lauren? Correct or not?
I have faith in your.
I didn't pay attention. I'll say yes. Marco, you're almost asleep, but just before you doze off. Correct or not? In your expert opinion? Justin, correct or not? Craig?
I'm too scared to say anything.
Why?
So much pressure.
I just want someone to confirm the code not correct. Okay, Marco and Justin are going to fight it out because one says correct and one says no. Craig? Do you want me to add 4.0? It's not a double. K is not a double, and N is not a double. And that division will be 0 or 1. Tish, yes. Okay. So now I'm a little afraid. If I do that, experts, will Java say, I've got a multiplication and a division to do? They have the same precedence, so they've got the same priority. I'll do them left to right. 4.0 times k is double times integer. I'll make k a double. I'll get 4k, a double value, divided by n, and I'll get the right answer. Or is Java going to say, I'll do the integer division first and get a 0 or a 1, and then multiply that by 4.0? But here Java could either say it's integer times double, which will make it a double, divided by integer, so I'll make that a double. Or Java could say, I'll do this division first. So that's double divided by integer, which makes it double times integer. Just to play safe, I'm going to change these around. I just swapped the 4 and the k, so to make doubly sure that nothing goes wrong. And then I'm going to print what I'm supposed to print, which is the value of pi. Hang on, give me a second. Pi, and then the approximation. What am I supposed to print? Oh, the absolute difference between this pi and the real pi. And I'll print one more thing. I'll also print the absolute difference between this pi and the pi I know. What's the value of pi? Okay. You remember a simple rhyme. Sir, I sent a rhyme excelling in sacred truth and rigid spelling. Okay? And then you simply count the number of letters in each of these words. 3 letters in sir, 1, 4, 1, 5, 9, 2. Couldn't spell sacred. Doesn't bode well. There are many such mnemonics. Okay. Pretty good. Right. So let's try again. Aha. Not great, but it's correct to 4,000th. Let's try again. Ah, better. Even better. Even better. Well, not even better. Worse again. Why do I get different values? Okay, so it's a random number of points. Sometimes I'm lucky, and the points fall accurately, and sometimes I'm not lucky. But this is pretty good. Do you have questions about this pi problem? Everybody knows. Somebody does have a question. Yes?
How perfect is Java's random?
What do you mean by perfect?
How random is Java's random?
What do you mean by random? Do you mean that, did we discuss in this class? Or did I discuss with my honor students? Do you want all outcomes to be equally likely? Is that not enough for you?
Very random.
What does random mean?
Very inconsistent
Each time to be inconsistent with every other time. Meaning what? What does that mean mathematically? You can't determine the next. But Java, the computer itself, is only a machine and only follows instructions. So somewhere inside the machine there is actually code, maybe even written in Java itself, that's making the next number. So it is possible, Justin, what's his name? Justin, Keegan, and what? Tristan. Oh, Tristan, Justin, Keegan, it's all the same. Tristan, somewhere there is code that is producing the next number, so somebody must know what the next one will be. Do you agree? So,
I mean, like if you get 1, then I say like with a job, you wouldn't be able to see. If you got that 1, you would form that to
yes, but what I'm saying, while you weren't listening, is that somewhere there is code that generates the next math.random. This code that executes. And if I were to execute that code, I would be able to predict the next one. So that's not random at all, is it? In fact, nothing on the computer can be random. We don't have a good definition for random numbers, and we cannot produce perfect random numbers, except in some weird circumstances where people use radioactive materials inside a little computer chip that is actually almost perfectly random, up to the randomness of the universe. Math.random, I think, is pretty good because it's producing these pi approximations, which it's good enough for us. Yes. Rightio. Anything else you want to ask me about pi? So let's look a little more. Yes, Keegan.
Sounds so depressed.
Well, I'm afraid I have to shoot you down if you're going to start wasting my time. But yes, or all our time. That would be terrible. Yes, interested. Yes. What do you mean by approximate? Well, there's a much easier way. I mean, that's pi. Thank you very much. That's pi, and that's also an approximation. It's not perfect pi because it can't be such a thing. I wouldn't say there's an easier way, but let's... Oh, one thing we didn't do, we didn't talk about Lorentz idea. Is it okay to just take the first square? Let's just try that, as Lorentz says, indeed. Okay. And I'll ask you a question, Lauren, afterwards. It seems to work perfectly. So why didn't we do it that way? No, we don't. We want to make it easier.
Because what if it did have we can't foresee all possibilities.
Very good. You're doing exactly the right thing. You're not just sitting like a zombie. You're making bullshit up, but you're doing something. You're thinking. Okay. No. The reason was exactly because I wanted to make things easier for you. And the idea of a circle and picking points on a circle and inside and outside the circle is just a fraction easier to explain than taking a quadrant and a quarter circle. And having to write the formulas now for a quarter circle is just slightly more tricky.
But you don't have to write this formula for a quarter circle because in our formula we're only using the amount of points, right? So that doesn't...
To get to this formula, to know that I have to multiply by 4, I had to think up this little formula. Nobody can just spontaneously say, hey, hang on, this ratio is not pi, but if I multiply by 4, I'm sure I'm going to get to pi. So you had to devise this little formula. That was the thinking part of the question. And to do that, I think would have been trickier with a quarter circle. That's why I kind of like put a nice full circle. Craig, I wanted to ask you something. Yes. Did you want to ask me something?
Yes.
Okay, hang on. Come here. And I shall give you one of my mics.
Okay, one off.
Yes. I'm a 2-mic household now. Okay. There you go.
Greetings, everybody. I am one of your class representatives, along with Stephanie over there and Rivaldo, over there we need to get your contact details so we can meet the WhatsApp group for us class representatives. But anyways,
you can message him on the Sunderland website.
We did. So, so we put some papers here that you've probably seen almost every single other subject give out with the class representatives. Pretty much just want your student numbers, your cell phone numbers if you want to, and whether you want to be on a WhatsApp group or a broadcast list. So, if possible, could you guys very quickly fill these out? We've got...
Hang on, before you fill it out, I would need to know some details.
Yes.
If I put my name on this list, what kind of stuff will you be sending me? Spam advertisements?
Okay, you will not be using spam advertisements. We will be sending important information. That
like
you
what?
need to know from like things like test, changing test information.
That's on the Sunderland website.
Yeah, but remember, we were under this assumption that people aren't exactly the most responsible when checking these things up. Things that also the NSC wants to send to you, any information information about events or information that they need as well. We are effectively going to be, well, I'm going to start having these out so you guys can put it on. You don't have to put your social numbers on if you don't want. If you really
What do you
are
want?
so inclined, it would be very helpful to
Nothing.
have student numbers and such. And if you have any questions or want to communicate anything such as how amazing of a professor we have teaching us and such like that, you can tell us and then we can kind of offer it to him. We don't want to be getting like too big a head, you know, so like, anyways. Thank you
Hang
very
on.
much.
Oh, thank you. Okay, still switched on. Let me just put this back in my corner. Okay. So, let's just, what I want to see, I wanted to see if, oh, man. Hang on. There we go. I wanted to see if the dates that I meet with the class representatives are on here and maybe even already passed. 1 March. Did we meet? Okay. 1 week ago. Are you available tomorrow at 1 o'clock? It is lunch. I'll take lunch. Stephanie? Checking. Rivaldo? You'll cancel whatever else is on. Okay, fine. So if you have particular complaints, if you find some of the demis revolting and want to have them replaced, or particularly nice and you want to compliment them, or anything like that, please tell Stephanie and Craig and Rivaldo. Well, don't bother with Rivaldo. No, tell Rivaldo. I'm just kidding. By clicking on this little link or sending a message to the WhatsApp group that will sure to spontaneously pop up. Okay, so they're on there. You can send them emails. And if Stephanie's available, we'll have a little meeting tomorrow. Science in context. What are you doing in science in context? Say again?
I'm not quite sure exactly what's going on, but kind of have to pass it. So
You have to pass it, yes. But it's not like life orientation. The idea is that it's going to teach you what science really is and how to do science researchy stuff. I never had life orientation. When I was at school, we didn't have life orientation at all. Was this high school? Oh, we just had like 1 sex ed class. And I think that was the whole of life orientation. It was called Jeugdweerbaarheid, which is youth robustness in English. Never mind that. Oh, I'll tell you a little story. We also had cadets when I was at school. So during once a week, we had to go and march around in little cadet uniforms. They were vulgar, brown, sludgy colored. And that's why I joined the band, because the band would practice in an air-conditioned room and go on tours and stuff. I played many instruments. I played the euphonium for a while, then I played the French horn. Later I played the trumpet. So.
Do you still have this instrument?
Now, when I was at school, I used the school's instruments. And then later on, I went abroad and I joined another band, and then I just rented a trumpet. So I've never been committed enough to the trumpet to own one. Okay, right. Let's get back to our class. We kind of have to stop. It's a little sad that I've only showed you pi, but I don't care. I know, Justin, that you are reading, you're up to date, and that you'll ask me questions. And If we only do programs in class, I'm fine with that. If you don't understand the concept that you read about, you must tell me so that we can discuss it in class and maybe do an example. Because you will have to use all these concepts. You've read about arrays. I hope you'll be using arrays in the next stat and in the project. So it's very important that you understand how they work. Oh, one more thing. Maybe we should have a test in tomorrow's tutorial. I think it's a particularly good idea. That lady is agreeing with me. She's vigorously nodding. Okay. Listen up. You have to write the test a week from Friday. So our first test is coming up on Friday, week, not this Friday, a week from this coming Friday. Friday the 16th. I don't want you, like the students of previous years, to riot and burn down one of the labs. So I wonder if it isn't a good idea if I gave you a mock test in tomorrow's tutorial. It could either be optional, so it'll just be there and you can take it, or if you want, we can simulate test conditions, so that during the first hour, we turn off the air conditioning so it becomes unbearably hot and stifled, and you're under pressure, not allowed to speak, and you have a time. I think that's best, a time limit. They'll get a different test next week, Tuesday. Or they can take this test, I don't mind. It'll still be in the TUTS, it'll be fine, yes. And I'll just make it optional. We won't have test conditions. Let's save that surprise for next Friday. Right. So tomorrow's TUT will have a mock test that'll be like the test that's coming, but not exactly the same. Now you're supposed to ask me mock test questions. Are we going to do arrays in the test? Yes. Do I have to study for the test? Not if you don't want to. Is it open book? No. Will I be able to write the test the next Wednesday because I want to go watch a movie on Friday? No. I have a horrible, debilitating disease. I have to go to hospital on the test date. Will I be able to write later? Depends on your disease and the progress. But if you bring me a medical certificate, you can write a makeup test at the end of the course. I have a clash. I almost said something bad. My French literature classes have a scheduling conflict with the test, and I cannot write this test. Can I write a makeup test? Yes. But those are the only two conditions. You have a scheduling conflict that I can verify in the system, or you have a medical certificate from a surgeon or a veterinarian or a pediatrician that says that you can't come. Right, listen. I'm just going to give you a very quick Afrikaans summary. Ons het gekyk na hierdie paai probleem van die tutoriaal. Dit is krities belangrik dat julle verstaan hoe om te dink. Nie noodwendig om hierdie probleem te skryf nie, maar om enige nuwe probleem wat jy sien aan te pak en op die regte manier te benader. Jy moet nie paniekbevange raak as jy 'n probleem sien wat jy dink jy kan doen. Jy kyk net na die dele wat jy wel kan doen. Jy skryf vir jou 'n opsomming of 'n buitelyn of 'n plan en jy vul dit in stap vir stap. Doen nie stukkies wat jy kan. Klasverteenwoordigers het 'n vorm aangestuur. As jy in Afrikaans verstaan nie, Engels verstaan nie, daar's 'n vorm. As jy jou nommer opsit, gaan jy op die WhatsApp groep kom. Say again? I don't know what a broadcast list is. What is it? What on what media? Oh, it's all WhatsApp. Okay, I don't care then. Okay, it's all WhatsApp. It's all WhatsApp. You put your number, you're on the WhatsApp. Okay? As jy nommer neerskryf, gaan jy op WhatsApp kom. So as jy nie enige boodskappe wil hê nie, Moenie 'n nommer neerskryf nie. Dis heeltemal privaat. Jy hoef nie 'n nommer te skryf nie. Waar is die lyste? As jy die lys het, steek jou hand op. As jy die lys het, steek jou hand op. If you have the list, okay, excellent, right. So don't leave without having looked at the list, all right? But the rest of you, I'll see either tomorrow or on Friday.